We do the quick recapture what we discussed yesterday. Any summary points? Yes, we studied about functional interface, the rules about functional interface. The functional interface can have only one unimplemented method. You can have many implemented default and static methods. And also you can have toString method or equals or hash code, which comes from object, which is not a count, right? To get the compiler verification, we can add the functional interface annotation, right? This is what we discussed. And also we discussed how to implement those functional interface using Lambda, as well as several API functional interfaces are available. We discuss how to implement those by giving simple examples, right? This is what we discussed yesterday. And today we are going to focusing on the new chapter, which is Java Streamed API. Okay. The Stream API is an abstraction of collection that supports aggregate operations like a filter and map. These operations make it possible to process the collection in a declarative style that support parallelism, compact and readable code, and processing without side effects. The same way of SA knowledge, deeper laws of nature are ultimately responsible for how things appear in the world. Efforts to modify the world from the surface level lead to struggle and partial success. Affecting the world by accessing the deep underlying laws that structure everything can produce enormous impact with little effort. The key to accessing and winning support from the deeper losses, going beyond the surface of awareness to the depths within by regular practicing of TM. So this is our agenda. See, we have 92 slides. Okay, so this lesson may take until Saturday, I hope. Okay, let's see, because too many APIs we are discussing. So for your better practice, I will type every code in IDE, then it will be easy for you. Instead of go through the demo code, I will type each and every code and execute on IDE. So that way you can easily get the concept. So that's what we are going to do it. These are our agendas. Let's go one by one. This slide about the definitions for stream. So which is from three different definitions we are looking. So the first definition is a stream is a way of representing data in a collection. So we have several collections in the collection framework, all collection framework and map collection and arrays also we can work with the stream. And that's what it mentioned. Few other data structure means arrays also you can work with the streams by supporting functional style operations to manipulate your collection. So for all the collections, we can perform some operations in a functional style. So for that, we use a stream. This is the new way of representing your data collection and performing the functional style operation. From the Oracle documentation website, the definition for stream is a stream is a sequence of elements supporting sequential and parallel aggregate operation. So we can perform parallelly as well as sequentially. You can work on your collection with the help of stream library. Stream provide a new way of accessing and extracting data from the collection. So these are all three different definitions for the stream. Let me know any questions on each point if you need more clarity. Why we need to go for a stream. So as we want to make our code thread safe and no side effects. Let's look at this imperative style of code. The count initialized with 0. Our requirement is you have some list of words, maybe from the who is representing on behalf of me, someone. Okay, so given a list of words, maybe from the textbook, we have collected several words and I want to make a count how many words are greater than 12. So in that, if we want to write a imperative style of code, I want to know the counts. So we need a counter variable and we need to loop through each input in your collection. Assume the list is your collection of words. Then we are going to write a code greater than or equal to 12 count plus plus. Now, if we transfer this code in a threading, multi-threading environment, there is a possibility to change the count because the counters easily can modify, right? Anybody can modify the state. So what are the issues with this code is the logic depends on the count variable and it is not a thread safe. So we want to perform a particular step of iteration and it says how to obtain the result, not what to do. So we don't want this imperative style. We want to move to the functional style. So what we can write it as word dot stream. This is your making into your collection into your stream. After stream, we can perform several operations. So we have filter. This will take a predicate operation, will return a Boolean value by satisfying this condition. Then I'm going to count. If we look at this code, it's purely functional and thread safe. There is no commitment for iteration path. So we don't need to worry about provider iteration. It has inbuilt iteration. It will loop through each element in your collection. Everything will be processed. So we no need to worry about the iteration. And I'm going to get a count, simply call a count method. So we no need to introduce any variable to maintain the status, right? It all happen in your stream collection. So there is no way to modify the status of count. So this code becomes a thread safe. And also if the collection is too big, I can do the same operation. Instead of stream, I can do parallel stream. So when you work on parallelly, the particular stream will be divided into several substreams and each substream will work on the remaining operations. To perform this, Java uses a framework called a fork join framework. Okay, so I will put the framework called fork join framework used for parallel processing. Parallel processing on streams. So parallel processing on streams, the framework. So that's what we want to learn, the functional style of coding. Then finally, with that fork join framework, we'll combine all the frame results into a single result. So this way it will work. So that's what we would like to learn, how to do the functional programming to learn now. Yeah.
Because we only have the one stream pool, not the JPM, right? So when we do the parallel stream, that is really faster than the stream because we only have one.
If your collection is that we have a comparison on chapter 7, I will show you when you can go for a single stream and when you need to prefer for a parallel stream. If a collection is very small, better to go with single stream. If a collection is too big, you have to go for parallel stream. We have some benchmark record to show that which one is good. I will show you at that time. Okay. Any other questions here? Okay, let's learn about the basics of stream and how to create a stream. Okay, some facts you need to be aware of it. Streams do not store the elements they operate on. Typically, they are stored in an underlying collection and they may be generated on demand. So what does it on demand is? I will explain the concept of streams are lazy, then you can understand it. So the stream is not like to store your collection like I can store it in your list collection, I can store it into a map collection set. But stream cannot be used for that purpose. The streams are used for some performance you can do with your collections with the help of stream. But stream is not for holding your data or you can store it and you can reuse it. That is not a purpose of streams. And also streams do not mutate their state. Instead, they return a new stream. For example, here we did only one filter operation. Again, I'm going to apply another filter. Now what will happen is every operations, it will generate a new stream, not the same stream, which means mutate, right? I'm not going to use the same stream for every operations, whatever I call. For each and every operations, it will generate a new stream. So that's the point for here. Okay. So all stream operations, whenever you call several filter map, another time filter map, how many times if you do, every operations will return a new stream. It does not reuse the stream from the previous collection, okay, which means the previous operations. And the next important point is the stream is an interface. I will show you from here how the list is interfaced. The same way your stream is an interface. So this interface has all unimplemented methods. So which has so many operations, whatever we work, which has all unimplemented methods. I hope we have some implemented methods. It's a big library. You can take a look at, is there any implemented methods? And where all these methods are implemented, like if you take a list, we have some abstract list class, which has some implementation. The same way your stream operations are implemented the class name, which is called reference pipeline. Okay, so you can look at the library, which has reference pipeline. So this class will implement the stream interface and put the behaviors inside here. Okay, so many methods. So if you look at here, this implements stream. So when you look at here, all the implementations are done inside this class. So that is the knowledge for this point. Please read out this facts point. Let me know if you need clarity. Okay, let's move to the next point. Okay, here all the stream operations are lazy. We have two types of operations on the stream. So one is a intermediate operation, which we'll talk soon after a few slides. Okay, so stream operations. Two types of stream operations. Two types of. Huh? Oh, I have to move a little. Can I copy and paste it in a Word file? Because I have to move a lot of things here. So better I can open a Word file.
I have a question on the screen.
One second, one second. Yes. You can learn. First, let's go over everything. Okay. See some examples.
After the collection, like the collection dot the filter collection.
Because in our existing API library, that does not have any functional style of coding, right? This is introduced from JDK 8. So for that, they introduce with the new library and they do everything here. Okay. So it's only from JDK 8. You cannot use pre-JDK 8. So that's what the new changes. The functional style happen only from JDK 8. Okay, so here, two types of streams we have. One is intermediate operations. So there are two types of operations. Two types of operations on streams. The first one is intermediate. Next, we have a terminal operations. Terminal. So all intermediate operations are lazy. Okay. And the terminal, once you invoke the terminal, then only your intermediate operation will start functioning. Okay. Your intermediate operations start functioning. So that's what we are going to say. All intermediate operations are lazy. We'll talk about what are intermediate operation and what are the terminal operation. That's what we are going to go through this chapter. So all intermediate operations are lazy. I'll show you some example to give you a better understanding. Okay, so here I have some list of names. Some array collections, array list of collection is populated. I want to stream this collection. That's what our next topic, how to create a stream. So as of now, just go with that. I have to stream my collection and I'm going to filter. The input is greater than or equal to 5. So I would like to show you how this operation is lazy. I'm going to print some values, whatever the stream has currently. So what the filter will take it is predicate. What the predicate will do? Take a input and return a Boolean value. So my input is yes. I would like to show you to print that one on the console. So this is an intermediate operation. Okay. When I run this code, nothing will be printed on the console when you execute this code. Okay. So let me comment line this part. So when you do this code, if I want to run this code, nothing will be printed on the console because we applied an intermediate operations. It does not work anything. So as we mentioned, on demand, only your intermediate operation will start executing. So when I invoke a terminal operation, then your filters will start work. Otherwise, it's lazy. It does not do any work. When we order, I need this result. Give me a count. Give me a collection. Something you ask, then only your intermediate operation will start working. That's what all intermediate operations are called, lazy. So now what I want to do it here is, I want to collect the names by applying a terminal operation. So here collecting a result is a terminal operation. So when I call this operation, what it will do? The filter then only will start work. So what we are going to do it is same line, but I apply the terminal operations collect. So when I do that, it will return a collection of strings which has greater than 5 length. So according to this scenario, I have three inputs which has greater than 5 length. So I'm going to print the size after collecting the result. So this operation will not execute until you invoke any terminal operation. So if I run this code, so let me comment line this part will not work anything. So now if I do this one, it will give you a result. See here. It will process the inputs one by one from the collection. The first input is Java because before the condition, I print the inputs. So all inputs will be printed in the filter. Then finally, after that, how many inputs you collected? 3, because only 3 has greater than of 5 length. So that's what stream operations are lazy. Until you invoke a terminal operation, which will not work. I will let you know what are terminal and what are intermediate. We'll discuss soon. Just an idea, knowledge you gain from this is why streams are lazy. Streams will not work until you invoke a terminal operation. So now you read this slide, it will give you clarity. Okay, please read out this diagram. This one, then I will explain this one. Okay, look at this code. We have several filter operation, map operation, limit operation. All these three will not work. Once you invoke dot collect, then all intermediate streams will work. So all operations are waiting, intermediate operations. So when I invoke a terminal, then your stream one, operation one will do. Then operation two, map, then limit, then finally you collect a result. Okay, please read out the slide and look at the diagram. If you need any questions, let me. What can you repeat your question? Intermediate? Yes, if we don't include the collect, so all the operation. No, does not work. They won't execute. Okay, you created a like work order, right? It is not assigned yet. So when you call a terminal, then only your intermediate will work. So if you don't have collect the same scenario, so what I show you here, it will not function anything, okay? You just created a code. Your stream does not filter anything, okay? But when you call this one, then only your stream will work on your collection. Otherwise, it does not work on your collection. Just the code is there, but no functioning. Okay. When you invoke, then it start working. That's what it's called lazy. On demand. Whenever you need, then only it will execute your commands. Any other questions here?
Based off terminal operation.
Yes, we will discuss that later. Okay, what are intermediate, what are terminal. Now you learn the concept of why streams are lazy. The streams are by default lazy. It won't execute until invoke a terminal. That is the knowledge. No implementation knowledge given to you. Yes.
The absence of terminal
Without terminal operation, you cannot. Whatever you do operation, you need to get some result, right? That is your output. When you want to get an output, you have to apply some terminal operation. Without that, we cannot do. Okay. Something like return. Your method can return something, right? You need to get an output. For that, you need to apply terminal. Without that, we cannot do anything. Okay. Okay, how can I create a stream? If you want to create a stream and if you want to work on the stream operations, there are 3-step template you need to follow. Step 1 is create a stream and you can make several intermediate operations. The third step is terminal. So you can have multiple intermediate operations, but one terminal. Because final, like a method can return one value, right? I cannot use multiple return. The same way, finally, you can collect one output, but you can do many intermediate operations. So this is your template. So I will start executing the code one by one. In your demo code, I will put the slide number also. That will be a good reference. Okay, so let's start with slide number 12. So for that, I have populated some integer collection and the list collection. Let's learn about the functions. I want to filter the names, want to collect as a list, which has greater than 5. Okay, so what is the template we learn? First step is create a stream. How can I create a stream? There are several ways to create a stream. Let's start with the first step and we have several options to create the stream, which we will discuss after a few slides. Okay. So what is your collection? Names dot. So the step 1 is create a stream. Without stream, you cannot do anything. So here is my object dot stream. So this is your step 1. Create a stream. So just your collection dot stream. That is the way to create a stream. So what is the next step? It is the chaining of functions. Whenever you until terminal operation, you can have multiple chaining. Okay. So dot. The next step is I want to filter. Still, we will discuss about more about the filter signature, everything. Just we understand the 3-step template now. Okay. We can filter the data what we have. I need to filter which has greater than length of 5. So this condition is a predicate. Always filter accept a predicate functional interface. I cannot substitute any other interface here. So what is the function of predicators? Take a input, return a Boolean value so that I can easily replace with lambda. So take a input, that is your argument, your lambda operator. What I need to return a Boolean value. It's like a if condition. So what I need to check that input dot length greater than 5. I filter. Then this is your step 2, which is your intermediate operation. So you can have many intermediate operation. We will go by integrating so many intermediate operations step by step. As of now, we are going with one intermediate operation. So what is my third step is I want to apply a collection to get the result. So for that, you have to call the method called collect. Inside the collect, we are going to call collectors class, collectors dot to list, to map, to set, whatever you want, everything is available. Okay, but I want to collect as a list. Just call collectors dot to list. Now, this will return a type of list of string. So retrieve these values, whatever return type you want, you can, depends on the terminal operation, you can collect the result. Okay. So result 1 is equal to this one, right? Okay. As we mentioned, all intermediate operation return a stream. Did you look at the signature? What the filter will return? Stream of collection. So whenever you use, so this is one stream. I have an input stream. When you collected, you have a stream. So that stream will be passed to the filter. So when filter going to next intermediate means the different stream will be passed to the next operation. We are not reusing the same stream collection. Every stream operations will generate a new stream. So what is the result of this collect? List string. So it will return a list of string. So if I want to print a list, I can print a list R1. Okay. If you want, you can do for each. Okay. So now I get a list of values which has greater than 3. So this is what a template. Create a stream. That is your first step. Second step is so many intermediate operations. You can have one or more. How many you want, you can go with several intermediate operations. So step 3 is one terminal operations. Look at the code. Let me know if you have any questions. Huh. What? What do you mean by multiple data? Huh? Yeah, you can call chaining off. Filter is an intermediate. You can call several times. If you want another filtering, put filter and also you can put under condition or condition. Okay, everything we can do. We'll go one by one, okay? So any question on this slide? Read out this slide. I'm going in a slow phase because you must get this understanding. This will be useful for your future courses. Whatever you take, they will use these futures. So here the example is I want to filter a name start with a letter. So the letter maybe you have to substitute or assign somewhere. That is a free variable. Okay, move to the next. So we have discussed the one approach to get a stream. If you have some collection, dot stream. So what are the other ways to create a streams? Let's discuss that one. Okay. So over here, I have an integer array. I want to make it into a stream of integer. So what I can do it is there is a method called stream.off. Then pass your integer arguments. It will return a stream of integer. Okay. So let's go with this one. The first one is always if you have some collection dot stream. Okay. Let's go for this one. Slide number 14. Okay. Let's go over the slide number 14 code. Which is several ways to create a stream. So I have an integer array. Let me copy and paste this code. So, now you might wonder, can I call stream with this? No. So for this one, you cannot call. So that's what when I call dot stream, I have no option. So the only option to create is call stream dot off. So this is a method, static method dot off, which we can pass your collection and retrieve as an integer because my input is integer. I'm going to retrieve as a collection. So here, what you need to do, stream dot off, pass your collection. So, and also you can pass multiple, this accept a varargs like 1, 2, 3 values also you can directly pass. Okay. So when you do this one, what is the return type? Stream integer. So I have to retrieve this one as a stream integer. Sorry, capital I. Stream integer. Let's put I1. Okay, int 1 is equal to stream dot off. Then what I can do, once you have this collection, you can do, it's a stream, right? So you can apply the next step, intermediate and terminal, whatever you want, you can do with them. Okay. So after this collection, you can do all the intermediate and terminal operation. Okay. I want to do the count. So what I can do it is how many elements in this out. So I can do int one dot count. Okay. So now it will print how many elements in the collection. Okay, so let's run this code. It will print 4 elements in the collection. Okay, what is the next approach? Okay, this is quite confusing approach. Let me tell you this one. I have an int array collection. I want to make it as an collection of the same type in my stream. Okay, so let me put this one. Okay, here is your collections of array of int. I cannot use the same name. Okay, here is your integer collection. Now I want here how it's stored. Each element is an integer collection, right? I want to store my result as a type of int collection, which means every input is a collection. It will hold single element, right? One by one. But I want to store as a type of this one. Yes, it is possible. As we all know that array is an object, right? So what a array of one? Is it primitive or object? Object. So you can pass this type. So array is an object type. So what the idea we are going to represent here is, I cannot store like this. This is wrong, right? Instead of that, you can store as a type of, okay, let me show you. If you want to store like this, it is illegal. Okay, so which is illegal? Illegal. But I can store string. It's an array collection. It's an object type. So definitely you can use object type. Int I2 into 2 is equal to what I can do? The same stream dot of put your collections. So I hope you understand the difference between the previous statement and this. That will store as a int value, but this is to store as a int array values. Okay, so now this is legal. Can I add one more value? Yes. So if I want to create another collections like 2, right? So can I do 2 here? This is also possible because you want to store, it will hold single item, single collection. I can even store multiple. Okay. So into 3, you can store because as we mentioned, if of method is a var arg, it accepts multiple values. Okay. So now your stream is ready. I want to print this one by one. How can I do this? I don't want to apply any intermediate operation. What I can do it is int 3 dot for each. This is also a terminal operation. So take a input. I'm not sure directly we can print arrays dot toString is needed. Let's see. Arrays dot toString of pass x. Okay, so let's run this. What happened? But I didn't print it, right? Put system.out.println. System. Arrays is gone. Right. So let's run this one. Okay. So maybe if you want, I can change some values. 8, 0. Okay. So if you run this one, I'll get this. So if you have some integer collections, if you want to make it into your stream, you have to use stream dot of method. Okay. So this is from slide number. Okay, take a look at this code. Okay, this is, I'll put in another comment line. Wave one is from array to stream, from array to stream. This one is collection of arrays, collection of arrays to stream. Okay. Oh. What? Yeah. When you print count, it will be 2. So I can print before here. So int, sorry, sys out count is equal to array count. It's my collection name, hint 3. Hint 3 dot will give you 2.
Because the line
Okay, so as we said, you can apply only one terminal operations because this for each is another terminal operate. Okay, so that we will discuss later, maybe third day. Okay, streams cannot reuse, so I cannot do this one. Okay. So only one operations you can do, either this or that. Okay, so that we will talk about later. I don't want to talk about that now. Streams cannot reuse. Okay, so count is a terminal. Again, if you call another for each, it won't work because you are, that is now more in stream. Okay, so that is in form. Okay, if it is a stream, you can apply all intermediate terminal, but there is no stream anymore. Okay, I apply a count. That's all. Your stream will not be available after terminal operation. So you cannot invoke another terminal operation. Maybe you can collect a result as a same kind of list of this type, then you can work on. Okay.
So how the line 35 store on the memory?
What?
Line 35.
Line 35 will store as a stream.
Yeah, but how it's store on the memory, how it write to the memory? Because they have.
It works on separate pipelines, everything. I don't know what kind of memory storage to process these collections. Every stream pipeline will execute all those operations. I'm not sure about which memory part for executing this, but it has its own pipeline, stream pipeline. Okay. We will talk about what are the terminal. Okay. Okay, so the next step is, okay, so here what we are doing in this step is take a integer number and make it into a stream of integer. So this will be cost effective. Better we have several primitive streams are available to make it more efficient. Instead of this one, we can use int stream of integer. Better we have all the types has primitive streams are available. So int stream, float stream. We have a separate slide about int stream. So we will talk about that. So instead of going with stream of integer, the best approach to go with the primitive stream. Okay, that's the point from here. Okay, that will be more efficient instead of going with stream integer. Better to use int stream. Okay, that will be efficient. So we have a conclusion about everything in the lesson what we have in the chapter 10. We are discussing about the conclusion about the streams over there. Okay, so this also will do. So now when you call int stream dot off, which will return a type of int stream. So I don't need to say the parameterized type like this. By default, it is an int collection. So you can apply all intermediate operation. Let's do collection dot filter, take the input and that input greater than, maybe I want to filter an odd number. Okay, so how can we do that? X modulus 2 equal not equal to 0. Is that correct? Do I need some operations? X mod equal to 2. Okay, dot count. Yeah, it works. Okay. So what is the count? Return type is long. Okay. So don't think as integer. Always count return a long value. If you want to get it as an integer, then you need to do casting. Okay. So sys out odd count equal to, I can put L, right? Okay. Why it says 0? There is no odd numbers. Oh, really? Oh. Okay, let's change to 11, 34, 55. Okay, 2. So better to go with the respective primitive streams that will be more efficient. Okay. And if I want to make a collection of string streams, so this is the approach. Even I can do by this way, make a collection of string stream, make a collection of stream of strings. So, okay, songs, some song collection. So after that, you can apply whatever operation. Just I want to print the values one by one. I can do song dot for each. So what I would like to do it is, do you know the method reference, right? System dot out colon println, right? So just loop through all the elements and I'm going to print it. So here is your stream. I'm going to apply the terminal. So this for each is a terminal operations. Let me write somewhere all the terminal operations. Count is a terminal operation. What else we have for each? So this is also your terminal operations. Okay. So let's run this code. It will print the values one by one from the song collections, right? So all 4 values will be printed one by one. So this is the method reference. If I want to print a line instead of lambda, this is easy. So simply I can give system.out.println. Questions? Okay, this is about the different ways to create your streams. And if I want to create an infinite streams, that are also possible. There are 2 ways to create an infinite stream. That will be generate and iterate. Let's look out that one. Which is slide number 15. Slide 15 about infinite streams. But we cannot do anything with the infinite stream. We have to make it into finite by applying some limit operations. Okay, these are all infinite streams. Okay, so infinite streams can create with the help of generate and iterate. Let me copy, paste here. Generate and iterate. Okay, let's see the signature. Okay, okay. If I use the generate, we'll accept a supplier interface. So this is the signature of supplier interface. When you work on supplier interface, no inputs, but return some value. So which means it can generate some infinite streams. Okay, here is an example of infinite stream. Stream.generate. Directly you can call a method called generate. So how can I do this signature implementation in Lambda? No input, but return a value. So no arguments, but I have to infinitely return something. Maybe a random number or your own numbers, whatever you want. Okay, let's do this one. So I want to print. Here is a requirement. Want to print Java infinite times. How can I do this? So you have to call stream.generate, which accept the supplier. Supplier means no input, but return some data. I want to return job. Okay. So now I need to print this one, right? So what I can do, dot for each system.out.println. Okay. So now it never stop. Okay. your program will keep continuing because it produces an infinite stream. Did you notice? Okay, so how can I limit this? Some intermediate operations we can do dot limit how many times you want. I need 5 times. Okay, just I can put 5 times. So just finally 5 times. So this way you can generate an infinite stream. So you can apply limit to restrict. Okay, apply intermediate. So this is an intermediate operation. Limit to make finite. Otherwise it is infinite. Okay, intermediate. What? Spelling mistake. It's a limit, right? The same way you can use, for example, I want to generate a random number. So what happened? Math colon random infinite times. So if I want to limit, you can, it will return a, okay, how can I store these values? Random values are in the stream double collection. So I can call this and apply all intermediate dot limit of 5 dot for each the same. So 5 random numbers will be printed. Okay, so 5 random values in the range of 0 to 1. I call math.random. So if you call random.next integer, you will get integer. So math.random will return a double value in the range of 0 to 1. So the same way I can use iterate. There are 2 approaches we discussed. One is generate, another one is iterate. So when you use iterate, for example, I need a odd number collection, I need a even number collection. In that scenario, I cannot use generate. So at the time, you can decide what type of data you want. So stream.iterate, which takes unary operator. So you should understand the purpose of the unary operator interface. What is the purpose here? Can anyone say that? What the unary operator will do? Take the input and return the input of same type. So what we are going to do it is stream.iterate. So we need some initial value, that is a seed value, and it accept the iterator will accept the seed value and your unary operator implementation. Let's do that one. Okay, what I want to generate here is the requirement is I want to produce 5 odd numbers. So how can I write this logic? I want to print 5 odd numbers using iterate. Print 5 odd numbers using iterate. Can you write the code? I will show you the signature. Okay. By this one. Can you write a code? I need to generate odd numbers. In paper. You can write it in a paper. You want to print the 5 odd numbers. 1, 3, 5, 7, 9. Okay. So stream dot iterate. You need a seed value. When you look at the signature, it will, sorry, when you look at the signature, it will show you, you need the initial value. So my first value start with 1 and by a unary operator implementation, take a input and input plus 2, right? I need odd values. Then it is an infinite string, but I need to print only 5 numbers. So I can apply limit 5, then dot for each. So when I run this code, it will print 1, 3, 5, 7, 9. I want to skip the first 3 numbers. Then after that, I need 5 numbers. We have a, you can start with that, but I want to skip the first 3 numbers in the sequence. Just skip how many elements you want to skip. So I skip 3 elements, then what will be your output for this? Limit 5. Skip first 3, limit 5, which means 5 numbers will be printed. Okay. So 7, 9, 11, 13, 15. So depends on. If I put the limit top, what will happen in this scenario? So light, I put here limit 5, then skip 3. Now what will be your output? 2 numbers. I limited only 5, but I skipped the first 3. It will print 2. So like that, we can print it. Okay. So 7 and 9. So like that, you can apply. So these are all intermediate. And this is an intermediate. Okay. So it skipped the particular numbers from the sequence, intermediate. Okay. So let's stop now. Okay. So that's all about this theory. It's time for break, right? So you can use skip. Okay. And I can give you this exercise. I think I did better. You can try this. Okay. 10 minutes break from now, 52, 11:05 I'll get back to you. 3 minutes for this exercise, 10 minutes for break. 11:05 we will continue the session.